what is the difference between VAV and VRF systems? I'm going to go over the pros and cons that I see for both. Check this out. I've got identical buildings here, identical air inlets and outlet placement, and I've drawn up a VAV system and a VRF system. So let's start by going over the differences in the dry side design. And the way I like to think of it is, in a VAV system, your primary conditioning and ventilation is happening at a system level, at the central unit, whereas with the VRF system, your primary conditioning and ventilation is happening at the zone level, at these fan coil units inside. So in a VAV system, your primary coils are in an air handler, maybe on the roof, and the air is already conditioned, and then it's distributed down a shaft through main ductwork before it gets to these VAVs, where the VAVs will vary the volume of the air to serve each zone. In a VRF system, the primary coils are at each zone. And with VRF, your return goes directly back to each zone. So you don't need a massive supply main and return main, which brings me to my first pro. VRF gets a +1 for having a smaller footprint, both on the roof because the equipment is smaller and also above the ceiling. And you'll notice here, the shaft could be much, much smaller. So what's this light blue line here? This is the outside air, or the ventilation air, going to each zone. This is going to be much smaller than a supply main because all you have to distribute on a system level for the VRF is any required ventilation for each zone. It's going to be smaller ductwork, which actually brings me to my second pro for VRF, which is precise ventilation control. Because we're not mixing our outside air at the central unit or at the system level in a VRF system, that means we do not have to accommodate for the space with the highest outside air ratio, and we can just deliver the exact amount of CFM needed for each zone. In short, you don't need to over-ventilate, which is a plus for efficiency. This is all great, but there's a giant pro for VAVs that I have to mention. VAVs are much less expensive. Just looking at equipment cost, each of these VAVs is going to be way cheaper than VRF fan coils. This is why VAV systems are still going strong, but we've got some more analysis to do. Let's look at the wet side. All right, here I've drawn up the wet side for each system. So for VAVs, this is our heating water, and for VRF, these are our refrigerant lines. And VRF gets another +1. Because water, or in this case, refrigerant, is a more efficient medium of heat transfer. Remember, our primary means for heating and cooling is running through these refrigerant lines in a VRF system, as opposed to the supply air in a VAV system. And refrigerant requires much less volume to move the same amount of heat as air. So it's spatially efficient, and you also have less heat loss. This also makes it more efficient. This is also where I want to point out that VRF systems have more efficient zone control. A VRF system can handle mixed zones much better, meaning some can be in heating and others can be in cooling, and it's not a problem. Whereas with VAV, if you have some zones in heating and some zones in cooling, you still need cold air going through your main ductwork, and then the VAVs will have to reheat that air if it needs to heat the space, which is not efficient. But VAVs are not out of the race. +1 for no indoor condensate. Typically, VRF systems require condensate lines at each of the fan coils. So that's more plumbing. With VAV systems, the condensate happens at the central unit, typically outdoors, and it's an easy solution. Now, there are some general things that we need to consider when it comes to the pros and cons of each system. Another +1 for VRF, it's got efficient ventilation control, an efficient medium, and efficient zone control, but also the equipment is generally just more efficient. So overall, your VRF system is more efficient, which should not be overlooked. This makes it easier to comply with energy standards, and a lot of times if you start with a VRF system, you're well on your way to exceeding any energy requirements that you have for your project. Another +1 for VAV systems is they are easier to engineer. With VRF systems, you need to be more precise with your load calcs. You have to pay attention to your ambient temperatures because that will affect the VRF capacity. You also need to account for the maximum allowable length in the VRF lines, which with rises and drops and fittings, that can get really muddy. And you need to run maximum allowable leakage calcs for refrigerant. So VAVs are just easier to design. With that, VAVs are easier to maintain. Fewer coils, fewer fans. And finally, just to even the playing field here, did I mention that VAV systems are cheaper? I think it's worth extra weighting because despite all the advantages of VRF, and yes, VRF is likely cheaper in the long run due to higher efficiency and lower operational costs, initial cost is still a huge factor. Because if you can't afford the thing, it doesn't get built. That's pros and cons of VAV versus VRF. I'm going to call it a tie, but I'll let you hash it out amongst yourselves.